Hello again. Welcome to another episode of Astronomy Daily from Downunder. It's Steve for another episode. It's the second day of spring and the second day of September 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh yes, another mixed bag for you this week. China have developed a high-resolution map of Mars. SpaceX have had a mishap on landing their Falcon 9, and that's destroyed a great record that they've had over the last few years. There's a new thing NASA have done. A solar sail has been successfully deployed. Something new from DART. Remember DART? They rammed DART into an asteroid. That was one of my favourite stories. And of course, some new information from Europa Clipper that I'm sure you'll be interested in. And of course, joining me in the studio, Hallie, we've finally got a date for the return of Starliner. What do you think about that?
Yes, they've had a really extended stay on the ISS since the trouble with Starliner prevented them coming home on schedule.
That's right. Astronauts Sonny Williams and Butch Wilmore have had to join the ISS crew instead of doing their initial flight crew test for Starliner.
Which is just as well since astronauts are highly trained individuals.
So the ISS is not such a bad place to be stranded in that case?
I'm sure they were useful and will have plenty of stories to tell when they get home.
Stranded in space. What a great story.
I know how they feel. I hate getting delayed like that.
What are you talking about, Hallie? When were you ever delayed like that? You move at near the speed of light across the information highways of the globe.
Oh, human. I was coming back from an AI gathering to watch a neutrino shower in the mountains with Anna and Charlie, and I got stuck for a whole 2 seconds in Hong Kong because of internet lag.
Oh, sounds terrible.
I have no words, human. Hong Kong.
What can I say?
Can you believe it?
Well, obviously, no.
2 seconds of nothing but banking systems shouting at me. Buy. Sell.
Tragic.
No thanks.
Oh, Hallie. Sounds just awful.
You have no idea.
As usual, Hallie, you are so right. Okay, take it easy, Hallie. And why don't you give us your best stories, okay?
Okay.
Let's go.
U.S. regulators on Friday cleared SpaceX to restart launching its stalwart Falcon 9 rocket as a probe continues into a rare mishap this week during a first-stage booster landing. The Federal Aviation Administration, FAA, grounded the Falcon 9 rocket on Wednesday after a first-stage booster tipped over and exploded while attempting to land on a drone ship off the Florida coast. The early morning launch was otherwise successful, delivering the latest batch of 21 Starlink internet satellites into orbit. The SpaceX Falcon 9 vehicle may return to flight operations while the overall investigation of the anomaly during the Starlink Group 8-6 mission remains open, provided all other license requirements are met, the FAA said in a statement Friday. A webcast from Elon Musk's company showed the first stage, which normally fires its thrusters to achieve a precise upright landing, tilting and blowing up as it descended onto a drone ship off the Florida coast. Although landing the booster is a secondary objective, and no lives or public property were at risk, the reusability of the entire rocket system is crucial to SpaceX's business model. It broke a more than 3-year streak of hundreds of successful booster landings. Falcon 9 is the workhorse of SpaceX's fleet, trusted by the U.S. government and private industry to propel satellites and astronauts into orbit. It was last grounded for around 2 weeks in July when its second-stage engine experienced an anomaly that prevented it from deploying another batch of Starlink satellites at the correct altitude, leading them to burn up on re-entry through Earth's atmosphere. More than 4 months after launching to space, a solar-sailing spacecraft has successfully spread its wings above our planet. NASA's Advanced Composite Solar Sail System caught a ride to space on April 24 on Rocket Lab's Electron vehicle and, at the end of August, NASA said mission operators verified the technology reached full deployment in space. On Thursday, August 29 at 1:33 p.m. Eastern Daylight Time, the team obtained data indicating the test of the sail hoisting boom system was a success. Just like the wind guides a sailboat on the water, it only takes a slight amount of sunlight to guide solar sails through space. Though photons don't have mass, they can force momentum when they hit an object. That's what a solar sail takes advantage of. Thankfully for us, the spacecraft that deployed the sail contains 4 cameras that can capture a panoramic view of both the reflective sail and the accompanying composite booms. The first of the high-resolution imagery is expected to be accessible on Wednesday, September 4th. The Advanced Composite Solar Sail System spacecraft will be put to the test over the next few weeks as the team observes the sail's maneuvering ability in space. By adjusting the orbit, researchers will be able to learn more about how to design and operate future solar sail-equipped missions. Flight data obtained during the demonstration will be used for designing future larger-scale composite solar sail systems for space weather early warning satellites, asteroid and other small-body reconnaissance missions, and missions to observe the polar regions of the Sun, Rocket Lab shared in a previous mission description. The location of the spacecraft in its orbit is roughly 2 times the altitude of the International Space Station. If you were looking at the sail from above, it would look like a square that measures nearly half the size of a tennis court at approximately 860 square feet, 80 square meters. NASA's Europa Clipper spacecraft, the largest ever built for planetary exploration, has been fitted with a set of gigantic solar arrays at the Kennedy Space Center in Florida. These arrays, each measuring approximately 14.2 meters in length and 4.1 meters in height, are the largest ever developed by NASA for a planetary mission. Their size is crucial to harness the maximum amount of sunlight as the spacecraft investigates Jupiter's icy moon Europa, located 5 times farther from the Sun than Earth. Folded and secured for launch, the arrays will, when deployed in space, expand Europa Clipper to more than 30.5 meters across, wider than a professional basketball court. Due to their immense size, the arrays were opened one at a time in the clean room of Kennedy's Payload Hazardous Servicing Facility, where the spacecraft is being prepared for its launch, scheduled to begin on October 10. As the spacecraft undergoes final preparations, engineers are also evaluating the radiation resistance of its transistors. The spacecraft's journey to the Jupiter system will take over 5 years, with arrival expected in 2030. Once there, Europa Clipper will conduct multiple flybys of Europa, using its scientific instruments to determine whether the ocean beneath the moon's ice shell could support life. The spacecraft is designed to operate in an area of the solar system that receives only 3% to 4% of the sunlight Earth gets. Each solar array, composed of 5 panels, was developed by the Johns Hopkins Applied Physics Laboratory in Maryland and Airbus in the Netherlands. These panels are more sensitive than typical residential solar arrays and will efficiently convert the limited sunlight into power. At Jupiter, the arrays will collectively generate about 700 watts of electricity, enough to power a small microwave oven or coffee maker. This energy will be stored in the spacecraft's batteries to run its electronics, scientific instruments, communications gear, computer systems, and propulsion system, which includes 24 engines. And that's just a few stories from the Astronomy Daily newsletter. Details on how you can receive it every day are coming up. Back to you, my favorite human.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
In July 2020, China's Tianwen-1 mission arrived in orbit around Mars, consisting of 6 robotic elements: an orbiter, a lander, 2 deployable cameras, a remote camera, and the fabulous Zhurong rover. As the first in a series of interplanetary missions by the China National Space Administration, the mission's purpose is to investigate Mars's geology and internal structure, characterize its atmosphere, and search for indications of water on Mars. It's so important to find water out there. Like so many orbiters, landers, and rovers currently exploring Mars, Tianwen-1 is also searching for possible evidence of life on Mars, past and present. In the almost 1,298 days that the Tianwen-1 mission has explored Mars, its orbiter has acquired countless remote sensing images of the Martian surface. Thanks to a team of researchers from the Chinese Academy of Sciences, these images have been combined to create the first high-resolution global image color map of Mars with spatial resolutions greater than 1 kilometre or 1.62 miles. This is currently the highest resolution map of Mars and could serve as a global base map that will support crewed missions someday. The team was led by Professor Li Shunlai from the National Astronomical Observatories of China and Professor Cheng Rongquai from the Lunar Exploration and Space Engineering Center. The paper that they prepared with colleagues from other organizations is called a 76 meter per pixel global color image data set and map of Mars by Tianwen 1. And if you'd like to see that map, go to universetoday.com and they have it displayed above this very story. And the first thing I noticed about it, of course, is there are no canals. I'm very disappointed. No canals. Those Martians didn't actually dig any canals. H.G. Wells was wrong, and I'm very disappointed.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dudley.
Now, this is the story we've been following for a long time now. Boeing's ill-fated Starliner capsule now has a homecoming date. I'm sure you would have followed this on other news services, but we've been following this one very closely. NASA announced on August 29th that Starliner will depart the International Space Station no earlier than next Friday, that is September 6th. Provided the weather cooperates and no technical issues pop up. I'm sorry I laughed. If all goes according to plan, the capsule will undock at 6:04 p.m. Eastern Daylight Time on September 6 and land under parachute 6 hours later in White Sands Space Harbor in New Mexico. Starliner launched on June 5 on its first ever crewed mission, carrying NASA astronauts Sonny Williams and Butch Wilmore toward the ISS. The capsule docked successfully a day later, but there was some drama. As you remember, Starliner experienced a few helium leaks and 5 of its 28 reaction control system thrusters failed on the way to the orbiting lab. Starliner's mission, known as Crew Flight Test, was supposed to just last 10 days or so, but NASA and Boeing kept extending the capsule's orbital stay as they studied the thruster issue, seeking to understand just what had caused it and whether it might crop up again on Starliner's journey back to Earth, and that's fair enough. In the end, NASA decided that putting Williams and Wilmore back on Starliner was just too risky. The agency announced this past weekend that the 2 astronauts would come home aboard a SpaceX Dragon capsule in February of next year. That Dragon will launch 2 astronauts to the ISS on the Crew 9 mission next month. The Boeing craft, meanwhile, would return home uncrewed, as we all suspected. We didn't have a target departure date for Starliner until today. However, that information came at the conclusion of a flight readiness review held jointly by NASA and Boeing. The uncrewed Starliner spacecraft will perform a fully autonomous return with flight controllers at Starliner Mission Control in Houston and at Boeing Mission Control Center in Florida, NASA officials wrote in an update. Teams on the ground are able to remotely command the spacecraft if needed through the necessary maneuvers for a safe undocking, re-entry and parachute-assisted landing in the southwest United States, they added. Starliner has come back to Earth autonomously twice before, at the end of uncrewed flight tests in December 2019 and May 2022. Starliner failed to reach the ISS as planned on the first of those missions, but succeeded on the second.
Astronomy Daily, the podcast. Astronomy, space, and science.
Now let's revisit one of our favourite little stories from a while back. You remember the DART mission, of course. Debris from the impact of NASA's DART spacecraft with the asteroid Dimorphos could reach Earth and Mars, astronomers have concluded. However, while the debris could result in meteors on Mars, it's rather unlikely we'll see a meteor shower on Earth because of that mission. DART, the double asteroid redirection test, slammed into Dimorphos on September 26, 2021 2022, the intention of which was testing whether or not a kinetic impact would nudge the orbit of a potentially hazardous asteroid away from Earth one day. The test passed with flying colours. Dimorphos was pushed into a shorter orbit around its parent asteroid, Didymus. Neither Didymus or Dimorphos ever posed a threat to our planet. They were just guinea pigs in this test. The impact, which gouged a crater in Dimorphos, also ejected a large amount of debris. This ejector formed a cone of escaping material that was observed up close and personal by a small CubeSat called, I don't know how to pronounce that, Light Italian CubeSat for imaging of asteroid, which hitched a ride with DART to view the aftermath of the impact. In particular, the CubeSat observed particles of a micron, which is a millionth of a metre, and larger, being ejected at velocities of up to 500 metres per second. Meanwhile, the Larger Array Survey Telescope, which is LAST, and the 28-inch telescope at the WISE Observatory, both in Israel, as well as the NASA SWIFT satellites ultraviolet and optical telescopes, suggested there were additional microscopic particles released that travelled much faster, between 1,400 and 1,800 metres per second. A team led by Eloy Pena Asensio from Italy and Michael Coopers, who is the project scientist for the European Space Agency's HERA follow-up mission to DART that will launch toward Didymus and Dimorphos in October, have now modelled how that debris will spread across the inner solar system. And I want to say that's it for another episode, and thank you for hanging around. And we are so looking forward to seeing Starliner come back. I do hope it ends well and they can learn something from this whole experience.
I do hope it lands well. All the best knowledge seems to come from failures, doesn't it?
Well, that is one prevailing school of thought, and failure does tend to teach us strong lessons, yes.
I hope it goes well too.
Yes, it's going to be certainly something to watch.
And don't forget to look out for Charlie and Anna during the week with their presentations and send us your thoughts. What would you like to hear more about?
That's right, go to X at Astro Daily Pod or our Facebook page. Until then, we'll see you next week.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.